Welcome to the lecture series on microeconomics. In the last lecture, we have derived the budget constraint of a consumer when the consumer faces a choice between present consumption and future consumption, and we have derived the budget constraint in that case. We have also introduced the concepts of present value and future value. Now, let us illustrate the budget constraint in the consumption plane and let us find out the consumer's equilibrium. And we are going to discuss case 2, and let us call this case 2a, where the consumer saves in first period. So, we will first start with the endowment point. So, let us assume that here is our endowment denoted by point E, and that basically represents fixed money income in period 2 and period 1. M1 and M2 are the coordinates of endowment point. So, now there will be some saving, right. So, now let us assume that consumer decides to save entire money income in period 1 for future consumption. Why do we need to assume this? Because when we are drawing budget constraint, then we have to find the extreme points, right. So, the extreme point along the vertical axis or future consumption axis will come from not only the endowment point that he or she has for that period, but how much interest plus principal he or she will gain from period 1's saving. So, that is the amount that we have seen earlier. So, suppose we are talking about this intercept, which actually represents M2 plus M1 times 1 plus R, because this is the interest plus principal in period 2 if he or she decides to save the entire money income M in period 1. So, then we need to join this two points, and we need to extend that so that it meets the x axis as well, and the x axis intercept will be M1 plus M2 divided by 1 plus R. So, that is the present value that we have discussed. And remember, we have spoken about two interpretations from the budget constraint. So, we have talked about the present value, here comes the second one, and that is basically the future value. So, we have obtained finally our budget constraint. Now, we have to superimpose our consumer's preference in this consumption plane such that we can have indifference map, and of course, we know that we are looking for the tangency point between an indifference curve and the budget constraint. So, the utility function, if you remember, is defined over consumption in time period 1 and consumption in time period 2. Now, if we are interested in the slope of the indifference curve, then what will be the MRS in this case? the marginal rate of substitution will be marginal utility of consumption in period 1 divided by marginal utility of consumption in period 2. So, let us write the slope of the indifference curve in this case, and that will be marginal utility of consumption in period 1 divided by marginal utility of consumption in period 2. Okay. Note that the slope of this budget line or the budget constraint is negative of 1 plus r, right. So, that is the slope of the budget line. Now, note that at equilibrium the slope of the budget line has to equal to the slope of the indifference curve. Sorry, I forgot to place minus here. So, then basically the minus and minus will cancel out, and finally we have mu C1 marginal utility from consumption in period 1 and marginal utility of consumption in period 2. The ratio of that, the MRS, will be equal to the absolute value of the slope of the budget line, which is basically 1 plus r, right. Now, that means that if r is positive, which is a pretty realistic assumption, then we have mu C1 is greater than mu C2. So, that means that the consumer values present consumption more over future consumption, and this feature is known as positive time preference. In fact, we can tell the story from the other way also, as the consumer has positive time preference, that is why we see the market rate of interest is positive. So, this is coming from the human psychology. This is not a very surprising result, right. People can sacrifice something in the present period only if they get more in the future time period. So, 1 unit of current consumption can substitute more than 1 unit of the future consumption. Now, let us explain the value of the slope of the budget constraint. Why we got negative of 1 plus r? Because rupee 1 today can be turned into 1 plus r rupees next period simply by lending it to the bank at an interest rate r. Now, we assume a typical consumer with standard indifference curve defined over C1 and C2 in order to find the consumer's equilibrium. Now, the equilibrium position is uncertain. There can be several possibilities. Of course, we can get back E as the equilibrium itself, or there can be far more interesting cases where we can get this tangency occurring in either the northwest part of the point E or in the southeast part of the point E. Let us first look at the case 2a, where the consumer saves in time period 1. So, that means that our consumer is a lender, right. So, if the consumer is a lender, that means that he is consuming less compared to his or her money income or endowment M1. So, suppose he or she is consuming only C1. So, if that is the case, then the consumer will go up and meet the budget constraint, and then from there he will or she will find the value of the future consumption. So, this point on the budget line, say let me call it point E1. So, that will basically give the consumption value C2, and we can write and we can draw an indifference curve which becomes tangent at this point E1. So, let us assume that this is the indifference curve denoting some utility level U naught in case 2a. So, E1 gives a lender's equilibrium. Now, let us continue with the discussion for a borrower. So, now we are going to assume that the person or the consumer has borrowed some money. So, that means his or her consumption point in period 1 shall be above M1, and let me assume that that is C1 prime here. So, if that is the case, again we have to follow the same procedure. We have to go back to the budget constraint to figure out the point on it. The y coordinate of that point will give the future consumption C2 prime, and this will be, say let me call this E2. So, this E2 point will basically give the borrower's equilibrium, and in that case we can superimpose the indifference curve in such a way that a new indifference curve, a totally new indifference curve, makes a tangent at that point E2. So, in case number 2b, say this is the indifference curve. So, if so, if that is the case, then we got E2 as the borrower's equilibrium, So, as we are talking about 2 or more time periods, one natural extension of this simple model could be adding inflation. There may be some inflationary pressure on prices of these commodities. So, if we assume a constant rate of inflation, how our model is going to be rewritten? Let us have a look at it. Let me assume the rate of inflation is given by this symbol pi. So, if there is inflation, P2 will become 1 plus pi. Remember, last time we have assumed the value of P2 equals 1. So, now let us go back to the case where the consumer is allowed to borrow and lend. So, if you go back to the previous slide, you will see that there we have expressed the budget constraint as the following. Now, if we assume inflationary pressure pi, then we have a new P2. So, this budget equation will now be rewritten as so, now we can introduce another new concept, which is real rate of interest. So, we can denote this complicated expression by a simpler expression 1 plus rho, and then the rho is basically the real rate of interest. So, the real rate of interest is equal to R, the nominal rate of interest, minus the rate of inflation. So, we have obtained a consumer's equilibrium and some related results. Now, let us do little bit of digression. Let us see how this small model or these simple concepts that we have discussed can be useful in some financial market analysis. So, let us talk about how to value an investment. We are going to discuss two applications of the concept present value. First, we are going to discuss the case of an investment. Now, in an investment, let us assume two time periods and there is some income stream or inflow of income. So, let us denote that by M1 and M2 respectively for period 1 and period 2, and there is some payment scheme or payment stream, that is basically outflow of money from consumer's pocket, and let me denote that by I1 and I2, these are basically investments made by the consumer. So, if that is the case, then how do we value the investment, whether the investment is beneficial for consumer or not? To judge, there is a concept called net present value that we are introducing now. that is abbreviated as NPV, and that is given by M1 minus I1 plus the present value of the net income in period 2, which is M2 minus I2 divided by 1 plus R. Now, of course, this can be extended to a third period also. So, how do we interpret these things? So, this M2 minus I and M1 minus I1 are basically the net cash flows, and we are looking for the present value of the net cash flows that is coming to the consumer. And how does a consumer decides whether to go for the investment or not? Of course, the consumer will benefit if the net present value results into a positive number. So, that means that the future value of the cash inflows is higher than the future value of the cash outflows. So, in that case the consumer makes a positive return out of the investment. Now, let us quickly look at another application of this concept of present value, and we are going to discuss a concept known as bond, which is very popular in financial markets. So, bonds are very common in borrowing and lending market. So, governments and corporations issue bonds, and that is basically a promise made to the consumers that if the consumer purchases the bond, there will be a continuous stream of payments for a certain period of time, and there will be a maturity period. At the end of the maturity period, the consumer will get the face value of the bond. And if that is the case, let us see how price of this kind of bond can be determined using the concept of present value. So, basically we are going to look at some income streams, and as the bond issuer has promised a fixed stream of payments, say x and so on and so forth, and then this is like continuous income stream, and then there is a maturity. At the maturity period of the bond, the person also gets the face value of the bond, right. So, in that case the present value can be written as x divided by 1 plus r x 1 plus r square and so on so forth. Suppose the maturity period is period t, that is a certain date. So, on that certain date, so we have derived the present value formulation in the case of a bond, and we can assume that this is the maximum price that a consumer is willing to pay for the bond, because if he or she pays more than this present value, then he or she is on the loss side, he or she is going to make a loss in this investment. Or if the price of the bond is less than the present value, then of course the investment will be a beneficial one for the consumer.